Okay, so I want to start, before I begin this video, by saying that if there is anything you want me to cover, any topic in science you wish me to cover, be it biology, chemistry or physics, do drop me a note in the comment section below and I'll happily cover that. It might help a bit more than me just randomly putting different videos up on what I think you might be struggling with. I mean, these are what are likely to come up, but if you need help with something, that's I'm happy to give you that. Okay, so this is one on chromatography. Chromatography comes up quite a lot, and they're really easy marks to get. That's why I'm going to tell you about this one. Okay, so first of all, what you've got here is what's called a chromatogram. It's basically once you've dipped a chromatography paper and you've got your results, then you've got a chromatogram. It's the equivalent of like a graph with the data on it. Okay, so let me just tell you what each part is called. So imagining this is our chromatography paper. The actual chromatography paper is what's known as a stationary phase. Okay, stationary phase, P-H-A-S-E. And then you will have dipped it inside some sort of solvent. The solvent, it could be water, it could be alcohol, and that's the liquid that actually slowly climbs up. And that liquid is known as the mobile phase. And you can always think of it as mobile is to do with movement. Yeah, that's why you had the mobile phones. It's like you could be on the move when you've got the phone. So the mobile phase is what's moving, and that's the liquid that's climbing up. You'll have your dots, which are the solutes, and then you've got this line here, which is your baseline. It's known as your baseline, and the baseline is where you draw it in pencil, and you draw it in pencil because you don't want it to mix up with your inks. You don't want it to dissolve in water, or in your solvent, whatever your solvent is. You don't want it to dissolve because otherwise it will carry it up as well and completely ruin your results. So you want that drawn in pencil, okay? And then this at the top is your solvent front. It's wherever, that solvent front is wherever the liquid climbs up to before you take it out. So if the liquid climbs up, so that mobile phase climbs up to that, all of a sudden you take it out, that will be your solvent front. If it climbed up to there, then your solvent front will be there. But there's clearly our solvent front. Usually in questions like this, they refer to some sort of food colouring or that really legally or illegally shouldn't be in some kind of food, or some kind of testing, or food dye, or some sort of question. Usually it's on that, but it's all to do with chromatography. So how does the chromatogram show that the food colouring is a mixture? Well, you would see more than one dot in a vertical line. It's important that you say the words vertical line because often you'll be given other sets of results and you don't want them to get confused with horizontal. Yeah. So you see more than one dot in a vertical line. And then this next one is on RF value. RF value is to do with retention. It's known as a retention factor. It actually stands for. You don't actually need to know what it stands for your exam, or what it actually means by definition. You only need to know how to calculate it. what you do is, first of all, you do your distance moved by your solute divided by the distance moved by the solvent. Yeah, so look at a nice equation here. So your distance travelled by the solute, that's assuming that's that dot. If I wanted to find the retention factor of that point there, I'd do that distance divided by the solvent, which is that distance, the mobile phase. Yeah. Now, if you're unsure in your exam, for whatever reason, you can't remember what divided by what, just do the one that's going to give you a decimal number, because your RF value is always a number lower than 1. So if you get a number larger than 1, then you've done it the wrong way around. Okay, so if you've done 39 divided by 7 and you get a number larger than 1, then you'd realize, actually, wait, hang on a second, I've done it the wrong way around. I'm going to do 7 divided by 39. And you'd get your answer there. Okay, so we can see that there. So it would be nice, yeah. So they like it if you write down the equation. Yeah. So write the equation. So once you've got that, once you know what you're dividing by, write the appropriate equation. Distance moved by whatever it is, divided by distance moved by a solvent, and then you do your calculation answer and give your answer to significant figures, because it asks you. Yeah. Don't forget that. A lot of people actually forget, when it asks you to give it to a specific number of significant figures. The RF value has no units, so you don't need to worry about any units. It has no units. Okay. Then this final question: plan a chromatography experiment to investigate the colours in an ink. I've seen quite a few 6-mark questions on this. It's an easy way to pick up 6-mark questions. It is a required practical, so just think back to it. What do you need? You need your chromatography paper. You need a pencil. You need a ruler. Yeah. Okay. So, and you need a beaker, and you need a solvent. In which case, we will use water in this instance. So, how do we do it? I'm going to talk you through how I'd structure my answer, regardless of whether or not these points are in here. Okay, so what I'd have is, so it says put dots of known colours and a dot of the ink on a pencil line on the chromatography paper. Okay, so what I'd say is draw a line about 2 centimeters up from the bottom. Draw baseline up about 2 centimeters from the bottom of the chromatography paper, and put a dot of the ink that you want to test, as well as dots of known colours along the pencil, along the baseline, and then place the chromatography paper in a beaker of water, making sure that the water level is below that of the baseline. Okay, so the water level has got to be, or the solvent has got to be below that of this the baseline, and then wait. So leave for the solvent to soak up through the chromatography paper, and when the solvent is near to the top of the paper, remove that and then put aside to dry, and then calculate. Okay, so you could say calculate RF values and compare to a known data table, but you might not want to say that. In this instance, you can just compare it to those from the ink. But if you do get a question asking you to compare it with dyes or something, you could do that. Anyway, that's all.